Hey everybody! So today we are going to learn on how to use the hypothesis testing to answer these questions. And before we begin, I just wanted to make it clear that this question is basically a pair dependent kind of data, and we have the machine one and machine two. Okay, so let's go to the questions. So here there are two machines that used to fill the plastic bottles with a net volume of 60 ounces. So in the second sentence, given here is the standard deviation for the machine 1, which is 0.02, and the standard deviation for the machine 2, which is 0.025. And yeah, this is I think one of the most important statement in the question given, which is you could use this to find the H naught. Here, a member of the quality engineering staff suspect that both machines could fill with the same mean net volume. Same mean net volume. So basically, your H naught is mu1 is equal to mu2, which means both machines are capable to fill the bottle with the same mean net volume. So automatically, our the H1 the H1 is the mu not is not equal to mu 2, basically saying that the differences between mean net volume of the machine 1 and machine 2 is supposedly not to be 0 for the H1, the H alternate. Okay, let's yeah, afterwards you could see that for this question we have to find the difference between each points that belongs to both machines. So basically we have for the first point we have 16.3, and then the second one we have 16.02. We have to minus the value from this here 16.03 to the 16.02, so you will get all these differences. I already made the table for you guys, so you could just see it this here 0.01 to the negative 0.01, and afterwards we have to square other values so that we could get all the positive numbers. So we just do the remaining 3, just the 1.6 times the negative 3, and oh, 1.6 times negative 3. Okay, and then 1 times to the negative 4, and 1 times 10 to the negative 4. Right, so we done the differences and the square root of the differences. And the next step is to find the t-score of the questions, which is I would say the main part. And the formula is the total of differences over the square root of n. Yeah, n here is basically the total number of samples. So you can see that in both machines we have 10 points of data, basically 10 samples. And n times with the sum of differences, sum of square of differences, minus the total of difference square, right, over n minus 1, right. So we just need to basically plug in, yeah, plug in all the formula inside the t-score formula. We have to plug in all this value d and d squared inside the formula to get the answer, the t-score, to suggest that whether to suggest or to suggest upon accepting or rejecting the H null. D, yeah, and the total d is the, yeah, so the total of d is equal to 0.1, and the total of d square is equal to 0.0242, right. So I just need to put the all these values inside the formula, and square root 10 times it is 0.242 minus 0.1, oh no, minus the, oh yeah, it's correct, minus 0.1 squared, and then 10 minus 1, right? So the answer would be 0.6228. This is the t-score, okay? So in this question, we are assuming that the alpha, the significance level is 0.05, right? So we have to find what is the t value that belongs to this alpha first, and we compare it to the value of the t-score that we get in the previous calculations. So we just need to draw a binomial, very smooth shaped one. And so yeah, I forgot to mention the degree of freedom, which is n minus 1. So we have 10 minus 1, junior school math, which is 9, right? So so we have to find what is the t value that belongs to the 0.05. This is two-tailed test. How do you know it's two-tailed test? Yeah, the trick is to just look at this here. You have this equal and non-equal. Basically, it's a two-tailed test. Two-tailed test. Okay. So we get back to the binomial distribution. So D is 0.05 and 9. So you have to make some line easier for you to find. This is degree freedom of 9. And then you have to find the value of 0.05 for two-tail. 0.05 here. Alright, found it. 2.262. So the t value is 2.262 for the alpha. Why? So it's somehow over here, right? The shaded area is the rejection area. And then we have, okay, I'm just gonna draw a dash line to indicate the middle of the distribution. And then we have another t value that we got before, t score of this question, which is 0.6228, which is somewhere around here, right? T score, and this is t value. So you can see that our t score is less than t value. It falls in the regions of a non-shaded region. So basically, whether to know it's accepted or not, yeah, of course, it is accepted, which is has the H null is not in the rejection area, which is the here rejection region. I'll say rejection region. So the H null is accepted, right? H null is accepted as it is not in the rejection region. And so get back to the question. The quality engineering staff is correct, as it suspects that the both machines are capable to fill the bolters with the same volume. So just write a few sentences. Engineers, S. Yeah, okay. Engineer is correct. Just to answer the question, so you will get the full mark. Okay. I think that's all. Thank you.